Let's get into solving some systems of equations with 3 variables. We've done it with 2 before. It's going to feel so easy once you do the ones with 3 variables in it. It's pretty wild. So what we're going to do is we're trying to whittle down the number of variables. Like when you had two variables, you tried to get it down to 1 variable because you could solve it. Here we have 3. If all the equations have 3, we're going to pair them up and try to get them down to 2 variables. So we're going to pair up the first 2 equations. Maybe. We're going to pair up the first 2. We're going to pair up the second and third. Now you can mix and match those. You could be like, all right, I'll pair the first and second and the first and the third. It doesn't matter. But you want to figure out which variable can you easily eliminate from both of them. So that might require multiplication, it might not. If you look at the first 2, our z's are already going to cancel out. And if you look at the second 2, or the second and third, the z's will also cancel out. That's pretty rare, but it's kind of going to warm us up into this idea. So I'm going to rewrite the first 2 paired up. So we'll say negative 6x plus y minus 2z equals negative 32, and 7x plus 5y plus 2z equals 27. We'll come back to that. I'm going to also write the second and third. You'll see there's actually a lot of writing that goes into each of these problems. So second and third, 7x plus 5y plus 2z equals 27, and negative x minus 6y minus 2z equals 17. So again, these are nice because they're already paired up to eliminate one of our variables. The z's are going to go away from both of them. So we don't even have to multiply them. And if you did, I would have done it before we wrote the equations again. But we could go straight down now. Negative 6x plus 7x is 1x. Y plus 5y is 6y. The z's cancel out. And then negative 32 plus 27 is negative 5. On the right side, 7x minus x is 6x. 5y minus 6y is negative y. The z's cancel. 27 plus 17 is 44. Now, this is crazy because you write so many numbers in one problem. You really have to pay attention because like one number off can totally derail the whole problem. Same as if like positive and negative mistake. And those are frustrating to try to find when you have to check your answers when they don't make sense. So be careful, take your time on these. So now what we're going to do is we're going to pair together these 2. These just have x's and y's. So we're going to pair them up together. X plus 6y equals negative 5, and 6x minus y equals 44. And we're going to solve this like a normal system of equations. Now we do have to get either the x's or the y's to match up, so we're going to have to multiply them. And in the future, I would do that before I even pair them together, so I don't have to write the same thing twice. But here we are. Let's just take the top equation, look at the x's. I have x and 6x, so I could just multiply the first equation by negative 6, and we'll be good to go. So that would give us negative 6x, negative 36y, and then negative 6 times negative 5 is positive 30. So here's kind of what we're looking at now. So 6x minus 6x, gone. Negative 1y and negative 36y is negative 37y. 44 plus 30 is 74. All of that to get there. So we're going to divide both sides by negative 37. And we get y equals negative 2. The nice thing is, once you solve for one variable, that's like the hardest part. So you just kind of backtrack it, and you're going to figure out the next variable, the next variable. So we're going to take it. We already know what y is. So we're going to take it back to when there were just 2 equations. And it doesn't matter which one we use. The x plus 6y equals negative 5, 6x minus y equals 44. Doesn't matter. Let's just go with this one because I have the space here. So 6x minus y is negative 2 equals 44. Now minus negative is really the same as plus positive. So this will be 6x plus 2 equals 44. We'll subtract the 2 from both sides. 6x equals 42. And then we could divide both sides by 6. And we get x equals 7. So we have x, we have y. We still need to find z. So we got to go back to one of the original equations that have a z in it. And it doesn't matter which one you solve. I always say, look for the one that looks easiest for you to solve. I'm going to pick the second one just because everything's positive in that one. And we're trying to stay positive today. So 7x, and we know that x is 7, plus 5y. We know that y is negative 2, plus 2z equals 27. All right, 7 times 7, 49. 5 times negative 2, negative 10. All right, we're going to have to combine our like terms. 49 minus 10 is 39, plus 2z equals 27. We'll subtract 39. 2z equals negative 12. And then we can divide both sides by 2, and we get z equals negative 6. Now we are going to write this like a coordinate. Usually it was like x, y. We're just going to put them in alphabetical order. So we're going to put x, y, z. So our x was 7, our y was negative 2, and our z was negative 6. Now in theory, what that means is if we were to graph these three on the same coordinate grid, this is where they would intersect each other. So like x and y are the 2 dimensions, and then the z would make it 3 dimensions. It would come off the screen. What? Oh my gosh, crazy. We're never going to graph those. Don't worry about that. But that's pretty tough. A lot of work. So let's try this one. Do you see anything that if we paired them up would be easier than the others to get eliminated? I don't know. If you look at the first two, the x's are already matched up, so we can cancel those out. The y's would be pretty easy. Z's would be a little tougher. Z's we'd have to multiply every equation. So I'm going to get rid of the x's first. So we'll pair up the first two. We'll pair up the last two. Now the first two, we don't need to multiply at all. The x's will already cancel out. So I'm just going to rewrite those over here. 2x minus y plus 3z equals 0. And negative 2x minus 3y plus 5z equals 0. The other ones, if you look, we have to get rid of the same variable. 2x and 3x. We can make them both 6x, or 6 and negative 6. So let's say I want to make this negative 6x. I would just multiply it by 3. If I want to make this one positive 6x, I would multiply it by negative 2. Don't forget, you got to do the whole line times those numbers. So 3 times this whole line would give us negative 6x minus 9y plus 15z equals 0. The last line times negative 2 would give us positive 6x, positive 8y, and negative 6z equals 14. Now all the x's are going to cancel out. So in the first two, no x's. The y's, we're going to have negative 4y. The z's, we're going to have 8z equals 0. Cool. We'll come back to that. If we look over here, the x's cancel. The y's, we're going to have negative 1. The z's, we're going to have positive 9. And then 0 plus 14 is 14. We're going to bring these two together. But eventually, we're going to have to get either the y's or the z's to match up and be the same number. I think it's going to be easier to get the y's to match up because I could just take this second equation and multiply it by negative 4. And I'm going to write that right underneath this other one. What? Negative 4 times negative y is positive 4y. Negative 4 times 9z is negative 36z. And then negative 4 times 14 is negative 2856. Cool. So now our y's get eliminated. The z's, 8 minus 36 is negative 28z. 0 minus 56 is negative 56. We'll go ahead and divide both sides by negative 28. And that gives us z equals positive 2. So we'll take it back one step to one of these equations where it just had two variables. We can use any of them. I'm going to use this one just because I have the space there. That's it. So this one was negative y plus 9z, and z is 2, equals 14. All right, so this will give us negative y plus 18 equals 14. We'll get rid of the plus 18 by subtracting it. Negative y equals negative 4, and then we could just divide both sides by negative 1, and y equals positive 4. We got y, we got z, we do need x, so we go back to one of the originals. You could use one that you multiplied, but the numbers are larger. Make your life easier, go with one of the originals. I think the first one looks the easiest. So it's 2x minus y, and y is 4, plus 3z, z is 2, equals 0. So this will give us 2x minus 4 plus 6 equals 0. We combine our like terms. 2x plus 2 equals 0. Boop. Subtract our 2. 2x equals negative 2. Go ahead and divide it by 2 on both sides. X equals negative 1. We'll just put them in alphabetical order. X, Y, Z. X was negative 1. Y was 4. Z was 2. Yeah, dude! We're doing it! Look at us! We are so smart today! Look at us! We're so smart! We got 2 more to do! Do you guys know that song? You should. You should learn it. Okay. Number 3. Anything look easier than the others? I don't know, but if I look at the second and third, the y's are already matched up. Okay, so this time let's try getting rid of the y's. Do you have to do that way? Of course not. When we pair up the first two, if I want the y's to be the same number, 6 and 5 go into 30. So that would require me to multiply the top by 5, the second one by 6. That would make them both positive 30y. We do want one of those to be negative. Easy fix. Let's just multiply by negative 5. When we pair up the second and third, we don't even need to multiply because we have positive 5y and negative 5y. So I'm going to start writing here. Top equation times negative 5 would give me positive 5x, negative 30y, positive 20z, and negative 5 times negative 15 is positive 75. This is my announcer voice. I'm trying. 6 times this line, 6 times 7x is 42x, 6 times 5y is 30y, 6 times 2z is 12z, and 6 times 21 is 126. We'll come back to that in a moment. The second and third equation. I wish I would have wrote over here instead. Hey, sometimes we make mistakes. I'm just going to rewrite them because we don't have to multiply them. 7x plus 5y plus 2z equals 21, and negative 2x minus 5y plus 7z equals negative 22. Sick. All right, back to the first pair. If we add straight down, we'll have 47x. We'll have no y's. We'll have 32 z's. 75 plus 126, 201. Oh boy. All right, the right side, we'll have 5x. We'll have no y's. We'll have 9 z's. And 21 minus 22 is negative 1. We are going to bring these two together. Oh man, this is brutal. So if you look at the x's, we have 47 and 5. I don't know what goes into them, but remember something you could always do is just flip the numbers. So I could multiply this equation by 47 and this equation by 5 or negative 5, and that'll work. Also, we could do the same thing with the 32 and the 9. Is there something they both go into besides whatever 9 times 32 is? I don't know. I don't think so, though. So we're going to have to multiply both. We're going to have to get some huge numbers here. Let's just go with the 9 and 32. So I'm going to get this first equation with 9, the second equation with 32. We do want one of those to be negative, so I'll make it negative 32. Let me grab the calculator. Whew. All right, this first equation times 9. So 9 times 47 is 423x. Plus 9 times 32 is 288z equals 9 times 201, 1809. That's crazy. That was the year my grandpa was born, 1809. We're going to do the second equation by negative 32. So negative 32 times 5 is negative 160x. Negative 32 times 9 should be negative 288. Let me double check that though. Okay. And then negative 32 times negative 30, or negative 1 is just positive 32. Whew. All right, for the x's, 423 minus 160 is 263x. There are no z's. 1809 plus the 32. Oh, I could have done that in my head. 1841. We'll divide both sides by the 263. Come on. Phew. Came out to a whole number, 7. We got that first number. It's just going to get easier, folks. So we'll take it back one step. We can use any equation with the x's and z's. I'm only using this one because it's got the space available. So 5x plus 9z, 5 times 7 plus 9z equals negative 1. 5 times 7 is 35. We'll go ahead and subtract that 35 from both sides. 9z equals negative 36. Oh yeah, you know we're going to divide it by 9. Z equals negative 4. We're still looking for that y. Why? Because we got to finish the problem. They all look pretty brutal. I'm going to go with the second equation, the 7x plus 5y. So 7x, x is 7, plus 5y, we don't know what that is, plus 2z, 2 times negative 4, equals 21. All right, this will give us 49 plus 5y minus 8 equals 21. If we combine our 49 minus 8, that's 41 plus 5y, or 5y plus 41 equals 21. I'm running out of room. Subtract the 41 from both sides. 5y equals negative 20. And then we can divide by 5 on both sides. We get y equals negative 4. Why you being negative 4? That's close. So x, y, z, our x is 7. Our y was negative 4. And our z was also negative 4. How cute is that? Whew. Man, these are tough, dude. Tough. Let's try one more. There it is. To me, looks easiest to get rid of the z's because the first two will already cancel out. So let's do that. We'll pair up the first two. We don't even need to multiply them. But the second and third, 7 and 6, they don't have any common factors. So we're just going to multiply 7 times 6, which is 42. So we're going to have to hit the second equation with a 6, the third equation with a 7, and then we should be good to go. So I'm just going to rewrite the first two again. 7x plus 6y plus 7z equals negative 33. The second one, 5x plus 4y minus 7z equals 13. We'll come back to that. Now we're going to multiply them. So 6 times that second line would be 30x plus 24y minus 42z equals 6 times 13, I believe is 78. But I don't want to make a dumb mistake, so let me double check that. It's 13 times 6. All right, 78. Second line, or last line times 7 would be negative 21x plus 21y plus 42z equals 7 times negative 24 is negative 168. Wow! All right. The first two x's, we got 12 of them. The y's, we got 10 of them. The z's, none. 13 minus 33 is negative 20. The other two, we pair them up, we'll have 9x plus 45y. No z's equals 78 minus 168. I should be able to do that in my head. But it's the end of the day. My brain is toasted. Cool. We got x's, we got y's. We're going to pair them up. Now you can always do 9 times 12. 108, you can make them both that. There is a smaller number than 108. They both go into 36. You can make that happen. The 10 and the 45, you can make them both 450y. That works. Otherwise, they do both go into 90. You can make them both that too. As long as you're making them the same number, you're good. I'm going to go with the 12 and 9, and I'm going to make them both 36. So it's 12 times 3, it's 9 times 4. We do want one of these to be negative. I'll just go ahead and do negative 3 times this one. So negative 3 times this equation would be negative 36x, negative 30y equals positive 60. When I do that second equation by 4, we'd have positive 36x plus 180y equals negative 360. All right, the x is gone. The y's, negative 30 plus 180, or 180 minus 30 is 150y. 60 minus 360 is negative 300. We could divide both sides by 150, and we get y equals negative 2. Cute. We'll take it back one step. You can use any equation. I've said it 4 times at this point. I'm only choosing this equation because there's the space there. Do whatever equation you want that has just 2 variables. So we have 9x plus 45 times negative 2 equals negative 90. We're almost there, folks. 45 times negative 2 is negative 90. Okay, so we can add 90 to both sides. 9x equals 0, and then we'll just divide both sides by 9. X equals 0. We have x, we have y, we do need z. I think the last equation looks easiest to me. Negative 3x, x is 0, plus 3y, y is negative 2, plus 6z equals negative 24. Negative 3 times 0 is 0. 3 times negative 2 is negative 6. So negative 6 plus 6z equals negative 24. We could go ahead and add the 6 to the other side. 6z equals negative 18. And then divide it by the 6. Z equals negative 3. Fun! X, Y, Z. 0, negative 2, negative 3. Tough stuff, dude, but we did it. We made it through. You guys are doing great.